What I want to do in this video is focus a little bit more on the results of the last video and make sure that they make intuitive and mathematical sense to us, because something slightly strange happened. We had a linear demand curve right over here, which means for any given change in price right over here, so in all of the examples, whether we went from A to B or C to D or E to F, we had a $1 drop in price. We had a $1 drop in price. $1 drop in price, and every time we had a $1 drop in price, we had a $2 increase, or sorry, we had a 2-unit increase in quantity demanded. So we had a 2-unit increase in quantity demanded. This is a linear demand curve. But despite the fact that for each dollar drop in price, we had the same increase in quantity demanded, the slightly maybe unintuitive thing that happened was we had a different, and actually a very different, elasticity of demand. And you might imagine that probably has something to do with the fact that elasticity of demand is based on percentage change in quantity relative to percentage change in price instead of just change in quantity over change in price. If it was just change in quantity over change in price, we would get something, it would be constant. But we saw very, very different results. And when you look closely at these, so let's focus on this region between A and B right over here. We had a $1 change in price. Our $1 change in price was on a relatively large base. Our price was already high. And remember, we use to figure out the percent change, we use $1 over the average of our 2 points. So we don't do $1 over 9, because then we would have a different elasticity when we went from A to B than when we went from B to A. $1 over 9 versus $1 over 8 would give you 2 different percentages. Instead, we say $1 over 8.5. So this price percent change was in the teens, while this quantity percent change is going to be was 67%, 2 over an average quantity of 3 in this region right over here. So you had a relatively large, actually quite large, percent change in quantity over a relatively small percent change in price. 67% over something that's roughly in the mid-teens percentage. And so that's why the absolute value of our elasticity of demand was a relatively large number. If you don't think about the absolute value, you get a negative number because this is a downwards sloping line. But if you focus on the absolute value, the magnitude of it is a relatively large number, a relatively large percent change in quantity relative to your percent change in price. And it all comes out of your quantities are low here. So if you move 2 on a low base, you're going to have a large percentage change in quantity, and your prices are relatively high here. So a change in 1 isn't going to be that large of a percentage. But when you have when your absolute value of your elasticity of demand is greater than 1, like it is right over here. So when your absolute value of your elasticity of demand is greater than 1, it's usually called, this point in the curve is elastic or generally elastic. So this is elastic. Elastic. You get some nice percentage movements in quantity for a given percentage change in price. Then when you go over here, our prices have gone, our price is lower when we're in this region between C and D. So that dollar difference is going to be a larger percentage change in price. And our quantities are higher. So that $2 change is going to be a lower change in quantity. And actually, they end up being the same thing, because you have a dollar change in price over an average base of 5, right? The average between 550 and 450 is 5. So you have a 20% change in price, a 20% drop in price, and you have a 20% increase in quantity. 20% increase in quantity. So let me write, this is in the teens over here. My writing's getting too small, so I won't do that. So you have a 20% change in price and a 20% increase in quantity. It's 20% because you have 2 over the average here, 2 over 10. So 20% increase. So that's why your elasticity of demand, or the magnitude of your elasticity of demand, is exactly 1. And if your magnitude of your elasticity of demand is exactly 1, we say that you have unit elasticity at that point. Elasticity. And then finally, if you go all the way down here, our prices end up being quite low. Our prices are quite low. So a dollar change is actually a huge percentage price change, right? Our average base here is $1.50 in this region right over here. And so $1 over $1.50, it's actually a 67% change in price. 67, yeah, that's right. Yeah, $1. It's a 2/3 change in price. So it's a huge percent change in price. But once again, now our quantity is much larger, so $2 increase isn't that large of a change in quantity. So you have a smaller percent change in quantity over a large percent change in price. So that means that you're relatively inelastic. You're not getting a lot of change in quantity for the magnitude of your change in price. And so if the magnitude of the elasticity of demand is less than 1 over here, we call that either relatively inelastic or just inelastic. Inelastic. So I'll leave you there in this video. And I want you to really kind of internalize what we're doing here, especially with the math, and especially understanding why the elasticities change here. Get you thinking in terms of percentages, and also make you, hopefully you appreciate why we're taking the average of these 2 points when we find the denominator for the percentages, instead of just taking one of the 2 points, so that we get the same elasticity of demand either direction we go in.